Hello, I am Shovan Maity from the School of Electrical and Computer Engineering at Purdue University, and today I will present our work on enabling new interaction modalities by communicating strictly through touch using a technique called Electro-Quasistatic human body communication. This is a brief outline of my presentation today. We will start with the motivation behind this work. In the current era of ubiquitous computing, users are submerged in a sea of computers with which they are constantly interacting, and touch is one of the most commonly used interaction methods. Simultaneous communication with touch can now enable new interaction modalities. Traditionally, it can be done by coupling a touch sensor along with some wireless communication protocol. However, these will suffer from selectivity and security as the signal is transmitted through air and is available to any device within a certain range and may get communicated even before touch. Now imagine if it is possible to communicate securely and selectively strictly during a touch event. Electro-Quasistatic human body communication or EQS-HBC potentially provides such a secure, selective and natural way of touch-based interaction between users and the environment. In this paper, we present the fundamentals of EQS-HBC technique, which enables strictly touch-based communication and demonstrate this property through 3 different demos. Now let's have a look into the background of human body communication first. Imagine a scenario when there are multiple devices around the body communicating with each other. Traditionally, radio wave-based communication methods such as Bluetooth will be used by such devices. Human body communication or HBC proposes to use the conductivity of the human body to use it as a communication medium between such devices. HBC enables the body to be used as a private communication channel by confining the signal within the body. However, there are certain limitations of current HBC implementations in terms of signal confinement. Most state-of-the-art HBC implementations uses signal in the tens of megahertz frequency range for communication. This results in signal leakage out of the body, which results in communication even without touch when the body is close to the receiver. Electro-Quasistatic human body communication is a solution to this problem. EQS-HBC confines the signal within a few centimeters of the body, as seen in the figure on the right. Now, if we look into the figure on the left, we see that when the hand does not touch the electrode, there is no signal received. Through signal confinement, EQS-HBC has now enabled strictly touch-based secure selective communication. Now we look into 3 different demonstrations showing these properties of EQS-HBC. The first demonstration shows the selectivity property of EQS-HBC. There are 2 receiver devices whose electrodes are right next to each other. The user transmits the rate code and touches one of the receiver electrodes. The rate code gets transmitted to the corresponding receiver, but the adjacent receiver does not receive that code, showing selective communication and minimal signal leakage from one electrode to the other. The second demonstration shows image information transfer between a wearable and a computer. When the user hovers his finger close to the receiver electrode, the image information is not received by the computer. When the user touches the electrode, the image information gets transferred from the wearable to the computer. The final demonstration shows secure authentication through touch. The laptop stays locked when the user with the correct unlock code has his finger close to the electrode. The computer unlocks only when the user touches the electrode. Any user with the incorrect code is not able to unlock the computer. To conclude, in this paper we present BodyWire-HCI, which enhances touch by coupling communication with it. The signal confinement property of EQS-HBC is used to enable strictly touch-based communication. This has been demonstrated using 3 different applications. Thank you.